Okay, Assalamualaikum. Kita continue our shear reinforcement design, the procedure. Okay, this is I call the design procedure 1, which is for theta is equal to 22 degrees. Okay, first kali kita kena find the VED. Okay, the shear force at the face of the support. Then the second step is we need to find the VED1 is the shear stress at the face of the support. So we notice that stress is equal to force divided by area. So this is the force. This we already calculate in the first step. So in order to find the shear stress, so force divided by 0.9 BW times with D. Okay. Then we need to find the concrete strut capacity, which is the VRD. Okay. We are using this from this table. Actually, the VRD here is calculating from this formula. So this is the common formula in order to calculate the VRD. So this is the formula. So for this case, theta is 22. So they already make simplify it in the table. So this is the strength of the concrete. So this is the concrete strut capacity. So which is the VRD. So let's say they are given concrete 30. So the VRD is 3.64. Alright. Okay, to ensure that there are no crushing of the diagonal compressive strut, so VRD must be greater than our VED, our shear force. Okay, so nak cakap kat sini, kita nak make sure yang tak ada berlakunya shear failure, kita mestilah design the VRD max to greater than our shear force. Okay. Alright. So we already have step 1, step 2, step 3. Okay. If the VED is greater than VRD. So this one we already calculate. The stress, the shear stress. This is the VRD. So if the VED1 greater than VRD, we need to follow the design procedure 2, which is I will describe later. Okay. For the use other value up to 45 degrees. Okay. In some cases, it may be necessary to use a larger beam or higher class of concrete. Maksudnya nak kata kalau theta lebih besar, maksudnya kita memang kena change the size of the beam, ataupun kita increase dia punya grade of the concrete. Okay. So let's say if VED is less than VRD, then we use theta is equal to 22 degree. And we need to follow the next step, which is step 6 to step 11. Okay. Step number 6. Okay. So, we need to find the VED2. Okay. So, VED2 adalah shear force at a distance D. Okay. Tadi tu at the distance, not the distance, at the face of the support. Okay. So, this one is VED2 is the shear force at a distance D. Okay, from the face of the support. Okay, so sama juga, ini adalah shear force. Lepas tu we need to calculate the shear stress. Okay, by using this equation. So, next step is step number 8 is calculate the area of the shearing force required by using this formula. So, since FYK is always 500, And this, so they just substitute kat sini, FYK is 500. So it will give us this equation. Then we can find the minimum ASW over S from this table. So let's say the grade is 40. So it will be the minimum ASW over S is 0.00101 BW. And then, right. So next step is step number 10. So we can follow this limit, which is the limit for the minimum spacing is 75, the maximum spacing is 0.75 T, but not more than 600 mm. Okay. Then the next step is step 11, which is choose a link size ASW and the link space S, so that ASW over S is not less than the value from step 8 and 9. So we already calculate the value of ASW over S. So we already know this value. So by using this value, so we can choose our link size and also the link spaces. Okay, so by using this table. So maksudnya dekat sini, ini adalah dia punya space, ini adalah dia punya bar size, dan ini adalah area of the shear link divided by the S. Okay, ASW over S. So this is the value. So we need to refer this figure. Okay, alright. So let's say the first example. Oh, before that, okay. In order to choose link ASW and the link space S, so that ASW over S is not less than value yang kita dah kira daripada step 8 dan 9. Dan daripada table tu, kita boleh decide sama ada we need to use a single link or multiple links. Okay, so kalau for single link, macam ni, ada 2 leg, 2 leg. Double link, maksudnya ada 2 link, so we will have a 4 leg, 1, 2, 3, 4. Okay, so ni another one double link, so they will have this link cover this area, and this link is cover this area. So same, we will have 4 leg, and if you use a triple link, so it will become like this. So 3 links here, so we will have a 6 leg. Okay, alright. So we continue with the example 6.1. So this is a simply supported reinforced concrete beam having a span 7 meter and 500 millimeter depth overall by 250 wide, and the width of the support is 150, and this is the characteristic load. Okay, so they given us the permanent dead load, not including the beam fabric and the variable imposed load. Okay, so the concrete grade is C40 and have 25 mm cover. Okay, as shown here. Okay, so dia dah bagi kita dia punya lebar, dia punya B dia bagi, H dah bagi, so D boleh dikira melalui perkiraan. So D sama dengan H tolak cover link and juga half of the diameter size. So dia dah bagi tahu size of the bar. Okay, so kita keluarkan balik. So beam width tadi B sama dengan BW. Okay, overall height 500. So effective span tadi dia kata 7 meter. Okay, so we need to calculate the force. The force is coming from the load given, characteristic action imposed dead load and also the imposed load. So I guess there is no problem how you get this one. So we already learned in the previous chapter. So this is coming from the third. So this is the force of the beam on top of the beam. So 258.5. So the concrete strength is 40. And okay, this the effective depth ni tadi yang kita dah kira, H tolak cover, tolak dengan link size, tolak dengan half bar of the diameter size. Alright. So effective depth dia adalah 452.5 mm. Okay. Yang kita dapat ini adalah boleh dikirakan sebagai point load ke atas beam. Okay, there is 7 meter punya beam, so akan ada satu force which is 258.5. So the reaction of this simply supported beam will have F divided by 2. Okay, 2.9.3. So if we draw our shear force diagram, so here we start with 129.3. Okay, so we need to calculate the VED1 and VED2. Okay, so we are given the width support is 150 mm. And the distance from the center of the support to the face of the support. Okay, this is the center of the support and this is the face of the support. Okay, is 0.075, which is half of the width of the support. Okay, so we need to calculate the VED. So we already know here the VED. So VED minus width. Okay, this is coming from the load. Okay, load, point load times with the area, the distance of the distance from center of the support to the face of the support. Okay, divide by 7. Sebab 7 ni adalah dia punya length of the span. So kita akan dapat VED1 nilainya 126.5 kN. Okay. So we need to calculate, then we need to calculate the shear stress. Shear stress sama dengan shear force divide by the area. So we got the shear stress 1.24. So shear stress ini mestilah lebih kecil daripada VR. So next step is we need to calculate the VR. Okay, so we already know the shear force, shear stress. Okay, daripada table, table 6.1 FCK adalah 40. So VRD dia adalah 4.63. So kita nak tadi VED ni stress, shear stress ni mesti lebih kecil daripada capacity value 4.63. So kita check less than, so it's okay. So effective depth kita adalah 0.545. So kita dah ada value ni. So sama juga value ni tolak dengan kita punya point load tadi, darab dengan dia punya distance divide by dia punya span. So dapat nilai ni. So ini adalah nilai untuk VED, shear dekat yang kedua. Then we calculate the shear stress at point 2. Okay. So then we can proceed with the next step. So step number 8, we calculate the area of the shear reinforcement required. Okay, so ASW over S. Okay, I think there's okay, we can calculate that we get this one. So we need to calculate the minimum ASW over S from the table 6.2, also refer by FCK 40. So kita akan dapat value ni. So maximum link spacing adalah 0.75. Okay, dari table ni kita boleh pilih kita punya H link kita akan dapat mesti lebih besar daripada yang kita punya